that sometimes can be the problem. It's the cooling that follows. This is a very, very powerful graph, and I'm going to walk through it slowly so you can see exactly what Mother Earth is telling us. And that is the value of looking at the information from the Earth herself. We're not seeing this interpreted through the eyes of a corporation or of a political or religious agenda. This is the Earth telling us her story. And the story is fascinating. In this particular graph, the year 0 to the right-hand side of the screen, that's us, that's where we are today. I'm going to go back to the 420,000 years from where the ice cores were in the previous graphs. And if you'll notice, you're looking at two colors, red and blue. The red are the temperatures of the Earth, the average temperatures, and the blue are the levels of greenhouse gases, particularly carbon dioxide. And I'm showing this because we're being told that it is the carbon dioxide and the greenhouse gases that is causing the temperatures of the Earth to rise and causing the concern. The data in this graph doesn't support that theory, and I want you to see precisely how this works. So if you follow with me, if we're moving from that 400,000 years toward the present, so we're moving from the left to the right-hand side of the graph, what you see is that the red lines rise before the blue. That means the temperature is rising before the greenhouse gases. And this is what's recorded in the ice cores in Antarctica and in Greenland. The temperatures rise first, and then the greenhouse gases, the carbon dioxide, follow, and there is a lag time. And it's not our imagination. This is from peer-reviewed science. This is peer-reviewed science that was published in the very prestigious journal Nature, volume 329 in the year 1987. Scientists knew this as far back as 1987. So I'm going to zero in on what it is that they said, and this is their language. They said when we are going from what's called an interglacial condition, and that's where we are right now. We're not in the glaciers, we're in between the time when the glaciers appear. So when we're going from interglacial into a glacial condition, into a time when the Earth cools, the change in the carbon dioxide actually lags the change in the air temperature. It lags, and that lag time is usually 4, 5, 6, 7, maybe 800 years. So there is that lag time. So this is from peer-reviewed science in the journal Nature.
Here's an example of a core that goes back some 100 to 200,000 years. And the sediments within this show clear differences visually, which have been caused by differences in climate. Now you can see here a whiter carbonate ooze, and here a red-brown clay. These carbonate oozes have been laid down during interglacial periods, warmer periods, and these red clays have been laid down during the glacial periods, cooler periods.